Welcome back to the Starman Report. There's been some exciting developments this week, so let's jump right in. NASA's Ingenuity helicopter survived its first night all alone on the surface of Mars. This was an important preparation test because temperatures on Mars can reach minus 130 degrees, which is enough to damage Ingenuity's battery and electrical components. To be able to survive on its own without the protection of the Perseverance rover, Ingenuity had to rely on its own battery and solar panels to keep it from freezing. So NASA has the first flight scheduled of the helicopter for 3:30 in the morning Eastern Daylight Time. So by the time this video is up on Monday morning, hopefully the first test flight has been successful. It's strange to me that how the fact that a person not being involved in the flight makes it seem less exciting, but it most definitely is. And we now live in an era of technology where all flights on the planet Mars are likely to be conducted autonomously, and that's because, quite frankly, software is now capable and can handle more complicated situations than a human pilot ever could. We've seen this evolution start to unfold already with the SpaceX Crew Dragon. When you compare its control system to the Space Shuttle, which had an unbelievable number of manual switches, versus Crew Dragon, which is controlled by just a few touchscreen monitors. So speaking of the Space Shuttle, although the NASA Space Shuttle program ended over 10 years ago, there's a much smaller unmanned version that's in operation today. It's called the X-35B spaceplane. Very little is known about this vehicle because it's primarily running clandestine missions to test top secret technology for the US Air Force and other government agencies. However, this week we got to learn a little bit about one of the technologies that's being tested, and it's pretty cool. So they're testing out space lasers. Well, sort of. They are running experiments on technology that's aimed at transforming solar power into radio frequency microwave energy. So the hardware is called PRAM-FX, and it's basically a 12-inch square tile that collects solar energy and then converts it into RF power. So in the recent test, they achieved about an 8% conversion efficiency. So to compare this to something you're familiar with, the solar panels on your home that converts solar to electric energy does so at about an efficiency of 20%. Keep in mind that solar electrical conversion has much more benefits of economies of scale and many more decades of development. So pulling off this solar to RF energy beam in space is actually relatively simple, but the real goal, and this is where it gets really exciting, is to absorb the sun's energy and broadcast that power back down to Earth as microwave radiation, so on Earth it can be converted into usable electrical energy. So we know Starlink is already delivering space internet. Might eventually we be signing up for star power to provide energy to our homes? The truth is, probably not. I don't think this technology is going to be suitable for broad applications, but it is really cool in special applications where we need to provide a significant amount of energy to very remote areas. As we move beyond Earth, humanity's needs for wireless power transmission is going to become more compelling. For example, in planning development of the moon base, we are going to need to mine the ice deposits for water. Well, those ice deposits are in permanently shadowed regions, so despite the extremely cold temperatures, we're going to need to provide hundreds of kilowatts of power to those locations so we can process the ice into water. Wirelessly beaming microwave power into the site may just be the perfect near-term solution to making this possible. I love technology like this. Its development is being advanced with both significant applications in space and also with many potential benefits to improving life on Earth. Imagine you have a disaster scenario or other things happening in the world that you need to get power to. If we have these systems in space that are already collecting energy into microwave radiation, all it would take is the appropriate receiver on the ground and you could start beaming power directly to that location. Look, it's going to be expensive, but I guarantee you it's going to have applications and we're going to see it being used to help save people's lives. Well guys, thank you so much for watching, and I look forward to having you back for more of the most exciting news in space.